But despite this wealth of data, despite radio and infrared, despite pictures to drool over, there still remains a problem.
One thing that we have been pretty uncertain about is the scale of our galaxy. Let us say we do know that the center of the galaxy is perhaps 8,000 parsecs away from the Sun, but perhaps it is 6,000 or perhaps it is 10,000. We want to do better. And now you ask, what are the means we have to measure distances in the galaxy?
Our image of the sky from one side of the Sun is slightly different to that from the other side. Stars closer to us should seem to move with respect to more distant objects. But because even nearby stars are so far away, this shift, hugely exaggerated here, is very difficult to observe from the Earth because of atmospheric effects. But freed from the Earth, a satellite could perhaps be used to determine the distances to the stars more accurately than could ever previously have been dreamed possible. Over a 4-year mission through the 1990s, a satellite called Hipparcos has accurately measured the positions and distances of more than 100,000 stars. It's a tiny fraction of the 100,000 million stars in the entire Milky Way, but it's an important fraction, for they are our Sun's closest neighbors.
Hipparcos is remarkable. It's revolutionising all our understanding of our local watering hole and much beyond. It's allowing us for the first time to be sure how old things are, where they are, and then we can go on from there to find out why they are.
And here you see the importance of the Hipparcos satellite. It has measured the distances, again, of a large number of these variable stars. So we now have the distance scale within the galaxy and outside the galaxy. We have now fixed it, we have put it on a firm base.
Hipparcos has created a new 3D world of the skies, a true route map to the stars. But incredibly, astronomers are already putting forward plans to go one better, a sort of Hipparcos 2, tentatively named Gaia. With an accuracy 100 times better than even Hipparcos, the new satellite would measure the distances and motions of nearly 1 billion stars throughout the entire Milky Way.
Whereas we now have from Hipparcos 120,000 stars, we will have comparable or even better data for millions and millions of stars.